All right, so vectors in a plane. Do you guys remember what vectors are? No, not at all. It's like those rays that you see in the coordinate plane. If you're looking here, if I draw my point, our vectors from P to Q, right there, where we have an initial point and we have a terminal point from that. Okay. Now, what we do here, quantities such as force and velocity, okay, involve both magnitude and direction. So what we're going to be doing is we're going to be finding the magnitude of these vectors. We're going to be doing a lot with them, but that's the main thing we're doing today. And the main thing is you cannot, when you're talking about magnitude, you're talking about force, velocity, you cannot completely characterize it into a single real number. So that's where these vectors come from. Okay. To represent, we are going to use a directed line segment. So we're going to start at an initial point and we're going to direct it to our terminal point. So depending on where it's at, it could be at 4, 3, it could be at -4, -5, something like that. Okay. The directed line segment of PQ, and if you notice, it has a part of a arrow there. Okay, has the initial point of P and a terminal point of Q. Okay, so our initial point, our starting point will always be P. The terminal point will always be our Q. Okay, its magnitude is denoted with 2 lines of PQ. Okay, so it's almost like the absolute value symbol, but you have the 2 markers there. Okay, and it can be found by using the distance formula. So to find its magnitude or length, it is used by the distance formula. Who can tell me the distance formula? Right. So this is our distance formula. Okay. Now the difference is obviously if we're using our directed line segment, it's P and Q. So instead of X, Y, we kind of look at this P's and Q's. That's all. Okay. So now show that vector U and vector V are equivalent. So is PQ, which is U, equal to RS, which is vector V? Okay. So to be able to find if they're equivalent, we have to know if their magnitude is equal. And can we find the magnitude of those two? Yeah. So let's go ahead and find the magnitude of, let's do PQ first, which is vector what? U. All right. So we're going to find the distance of that. Okay. So when I'm looking at P and Q here, we're going to find our distance. So what are my X coordinates of P and Q? What are my X coordinates of P and Q here? Might need to zoom in a little bit. What is my X coordinates of P and Q? 0 and 3. And does it really matter the order you subtract those in? Now my formula, I put x1 minus x2, but we're squaring it. So does it really matter how we subtract those? No. And then what are my Y values? 0 and 2. So can I just do 2 minus 0 again? Yeah. All right. And now let's do orders of operation. 3 minus 0. 3. 3 squared is 9 plus 2 minus 0. 2. 2 squared is 4. So what is 9 plus 4? 13. So we get the square root of 13. So the magnitude or length of vector U is the square root of 13. Okay. Now, could we now find the magnitude of RS, which is vector V? We do the same thing? Yeah. So let's go ahead and do the same thing. So what are my x coordinates of R and S? 4 and 1. So again, does it matter my order? Nope. What about my y's? 4 and 2, right? Now let's do orders of operations. So parentheses and then exponents. 4 minus 1 is 3. 3 squared is 9. Plus 4 minus 2 is 2. 2 squared is 4. And again, 9 plus 4 is 13. So are the lengths of P and Q the same as R and S? Yes, it is. All right. The component form of a vector, okay? The directed line segment whose initial point is the origin. And again, what's my origin? 0, 0, right? Is the most convenient representation of a set of equivalent direct line segments, okay? So if we can get it to the origin, that's the best, okay? That vector V is known as in standard position. Okay, so if the vector is at the origin, okay, the initial point is at the origin, it is known in standard position, okay? So the initial point would then be at 0, 0. My terminal point can be anywhere, and we're gonna label it as V1, comma, V2. So that terminal point could be at 3, 4. It could be at -2, 5. It could be at -3, -2, anything like that, okay? The component form of the vector V is written as V1, comma, V2. And instead of using parentheses, I kind of use these symbols, okay? All right, so now how do we find the component form of a vector? Okay, whose initial point is now P1, comma, P2, and the terminal point Q is Q1 and Q2, okay? To find that, okay, this is what you're gonna do, okay? So PQ, you're going to take Q1 minus P1, comma, Q2 minus P2, okay? So to get our component form, you always take the terminal minus the initial. Terminal minus the initial. And when we get that, when we actually subtract it, that will get you your V1, comma, V2, which will be known as your component vector of V. Okay. The magnitude or length, how do we find magnitude or length? How do we find magnitude or length? Distance formula, okay? So the magnitude or length of our V, okay, of our component vector is actually found by taking the square root, again, our distance formula of Q1 minus P1 squared plus Q2 minus P2 squared. But let's make that shorter. All right, let's make that a little bit shorter. What does Q1 minus P1 actually equal? From the component form, what did our Q1 minus P1 actually equal? P1. So I could actually just take my component vector of V1, square it, plus what's Q2 minus P2? P2, and square that. So if I know my vector, my component vector V, we don't have to go through and subtract our terminal minus our initial squared, all of that. We could just square both of the component vector and add them, okay? If the magnitude is 1, so if the magnitude of V is equal to 1, then V is known as my unit vector, okay? If my magnitude of that component factor is 0, Okay, it's more of if the magnitude of that vector is 0, if and only if C is the 0 factor. That should be 0, not 1. Okay. So if C is the 0 vector Z, then the magnitude will always be Z. Okay. All right. Example 2. Find the component form and magnitude of the vector V if its initial point is 4, -7, and the terminal point is -1, 5. My initial point is always what? Is that my P or my Q? My initial is always my P, and my terminal is my Q, right? So to find the component, do I subtract my P from the Q or the Q from the P? So what do I do? P minus Q or Q minus P? Q minus P, right? We always do terminal minus your initial, right? Because your terminal point is going to be farther than your initial, right? From the origin. So let's do our X. So our Q1 is -1 minus, what's P1? 4. So Q minus P, comma, Q minus P. So what's my Y coordinate of my Q? 5 minus, and what's my P? -7. So what is -1 minus 4? -5. And what's a 5 minus -7? 12. So my vector, my component vector, V, is going to be -5, comma, 12. If you do initial minus terminal, you would get a +5 and a -12. Is that the same? No, they're not the same coordinates, are they? No. All right. Now, from here, can I find my magnitude of it? Yeah. Magnitude is our distance formula, right? And again, I could have done the Q minus P, then square it, but isn't that the same thing as my component vector? So couldn't I just take the square root of my -5 squared plus my 12 squared? Is that going to be the same? Yeah. So what is -5 squared? 25. And what is 12 squared? 144. So what is 25 plus 144? 169. And what's the square root of 169? 13. So the length of my component factor, or even of P and Q, is going to be what? 13. Okay. So shifting these 2 points to the origin would get us to 0, 0 being my initial, down to -5, 12. Okay. Does that make sense to you guys? Yes, no? All right, vector operations. Remember in chapter 8 when we did scalar multiplications for matrices? When I had like 2 times the matrice of something, we just take the outside number and multiply to everything inside, right? So same thing here. Scalar multiplication of here is like taking any number k and multiplying it by vector v. Okay. So when you look at the scalar multiple of k times u, okay, if my u vector is u1, comma v, or u2, sorry, u2, if I'm multiplying k by that vector, so ku, that would mean I'm going to be taking k times u1, comma k times u2. So I'm just taking k and kind of distributing it to both of the coordinates. Makes sense, right? Okay. For vector addition, okay, would be like taking vector u plus vector v. Okay. So if U is U1, comma, U2, V is V1, comma, V2, to go and add that, okay, so the sum of the two vectors would just be the vector U1 plus V1, comma, U2 plus V2. So you're just going to add each coordinate of that vector. That should make sense, right? So example 3. We're going to let vector V be -2, comma 5, and vector W be 3, comma 4. Find each vector. So A is 2V. So that means I'm going to take 2 and multiply it by, taking 2 and multiplying it by vector, what? V. And what's vector V? -2, comma 5, right? So I'm going to take 2 times every coordinate, okay? So what's 2 times -2? -4, and 2 times 5 would be 10. So 2V would equal the vector of -4, 10. All right, B is asking for vector W, which is 3, 4, and we're subtracting V, which is -2, 5. So can I subtract each coordinate of the vector? Yeah. So I'm going to take 3 minus a -2, comma 4 minus a 5. So what's 3 minus -2? 5. And 4 minus 5 is? So the vector of V minus, or W minus V is 5, comma -1. Right. And then C, we're taking vector V, which is -2, 5, and adding it to 2 times vector 3, 4. So what would I do first? Would I add or would I multiply? Multiply. So go ahead and multiply 2 times vector W. And if I take 2 times vector W, what did you guys get? Yeah, so 6, comma 8. And then if I'm going to add the vectors, can I just add the coordinates? Yep, so I'm going to take -2 plus 6. And what's -2 plus 6? 4. And then 5 plus 8 is? Okay, and I put a plus there. Any questions with that? Pretty simple. Yeah. All right. Let's do properties. Do you guys remember all your properties? Like commutative, associative. You might not remember the names, but can you apply them? Yeah, I hope so. If I have U plus V, what is that going to be equal to? V plus U. Isn't that the commutative property? You might not remember that name, but it doesn't matter the order you add things in, it's going to stay the same. And the same is true for vectors, okay? What do you think U plus 0 would equal? U, yep. Does anyone know that property name? Nope. Identity, yep. Adding to 0 gets you back to itself, identity. All right, what about C times D times U? Huh? C, D, U. Yeah, so I can multiply C times D first, then multiply by U, couldn't I? What property is that? Switching the order of 3 things. Associative, yeah. You don't need to know the names, but I'm just going through them. What about C times the quantity of U plus V? So CU plus CV. What property is that? Distributive, yeah, exactly. And you guys do know that like C and D are my scalars. U and V have been my vectors, right? Okay. All right, and then the magnitude of CV, C times V, is actually the absolute value of C, okay, which is your scalar multiple, times the magnitude of V. That is new to you guys. So you'll take your scalar number, take it, the absolute value of it. So if my scalar multiple is a -5, you would use it as a +5, okay? Times the magnitude of V. And how do we find the magnitude of V? Magnitude is the length. So you use the distance, which is your x or v squared plus v squared, right? Square root of that. All right. Looking at f, u plus v plus w is the same thing if I took u plus the quantity of v plus w. And that again is the associative. Ooh, u plus negative u equals 1. Or u plus negative u equals what? 0. Equals 0. What property is that? Starts with an I. It's not identity because you get back to your original inverse. It's an inverse property. Yeah, it's okay. It's okay if you didn't know that. What about C plus D times vector U? Wouldn't that still be CU plus DU? And that's distributive property. So you can either add C and D, okay, the numbers, right? Then times it by the vector, or you can times the vector by each one of those individually, then add them, okay? And then 1 times U is U. That's identity, right? And then I forgot one more. So IJ is 0 times U. What's 0 times U? 0. That's the multiplication property of 0. All right. All right, so we're going to let U be the vector of 1, 3, and V be the vector of -2, 5. Find the magnitude of each scalar multiple. Okay. So what property of these am I using? Which one's the only one that has magnitude? Isn't it E? Yep. So with this case, our C is our scalar, and then obviously U is our vector. So we're going to take the absolute value of our scalar times the magnitude of my vector. Okay. And how do we find the magnitude of our vector? We take our coordinates and square them. It's the distance, right? Because we're looking at these vectors of 1, 3. Our initial point is at 0, 0, right? So it's pointless to do the whole distance formula because 1 minus 0 is going to get you back to 1 anyways, right? 3 minus 0. So we're looking at 1 squared and 3 squared, and then we'll times it. What's the absolute value of 2? 2, right? So 2 times. What's 1 squared? 1. What's 3 squared? 9. 1 plus 9 is 10. Can I take the square root of 10 or simplify the square root of 10? No. So the magnitude of 2 times U is just 2 radical 10. Now, do you guys understand why it's the absolute value? Why that would work? Because think about this. If I would actually multiply 2 times 1 or even -2, once I square it, it won't always become a positive number anyways. That's why. Okay. So this is one of the, obviously the property we use. We could have potentially taken 2 times our vector, which would have got me 2, 6, right? Then use my formula. But when you do that, when you have to simplify the radical, this is kind of helping you kind of eliminate that simplifying the radical sense. Okay. All right. B, magnitude of -5U. So I'm going to take the absolute value of my scalar. What's my scalar? -5. And then we're going to take the magnitude of u. Guys, do we already know the magnitude of u? Yeah, what do we find our magnitude of u was? 10. I'm not going to redo that. And then what's the absolute value of -5? So this is actually 5 radical 10. And then, see? So the magnitude of 3v would be the same thing as the absolute value of what? 3 times the magnitude of v, right? What's the absolute value of 3? 3 times. Now we need to find the magnitude of v. So we're going to take our v1 squared plus our v2 squared. And what's my v1? -2. And what's my v2? So what's -2 squared? 4 plus what's 5 squared? And what's 4 plus 25? And can I simplify the square root of 29? Nope. So we get 3 radical 29. Does anyone want to see it without using the formula? Going back? No, are we good? Okay. All right. Unit vectors. Okay. All right, so we got to add a little thing here. All right, unit vectors. Okay. Unit vectors are found by taking our vector v over or divided by the magnitude of v. Okay. Which then is equal to actually 1 over the magnitude of v times vector v, right? Aren't those equal to each other? Yeah, okay. Now, what this will get to us, okay, unit vectors, okay, unit vectors, their magnitude is always equal to 1. So once we get our unit vector, if we go to find the magnitude of it, it should equal what? 1. If it doesn't, then you did something wrong on your unit vector, okay? All right, so find the unit vector u in the direction of v, -2, 5. Verify that that magnitude of that unit vector is 1, okay? So first, let's find the magnitude or the unit vector of v, okay? So to find our unit vector, we're going to take our vector v. What's my vector? -2, 5, and divide it by the magnitude of that. Well, how do I find the magnitude? The distance formula. But again, we just have one thing, so our initial point is at 0, 0, right? So can't I just find the magnitude of v by taking the square root of -2 squared plus 5 squared? And we already know that. What is that? Square root of 29, yeah. Because -2 squared, 4, 5 squared is 25. Okay. So now my unit vector is -2, 5 divided by the square root of 29. You guys okay with that? Now, obviously, that's not a vector form, right? So that's why we break it up into this so that we have a scalar times my vector, right? So this here is the same thing as 1 over radical 29 times the vector of -2, 5. Are you guys okay with that? And now, do we actually know how to multiply a scalar times a vector? Yes, how do we take a scalar times a vector? How do I take a scalar times a vector? Don't I kind of distribute it in? So I would actually have, for my unit vector, what's 1 over radical 29 times -2? Is that -2 over radical 29, comma, which we have to rationalize that, right? But we'll get to that in a second. And then what's 1 over radical 29 times 5? 5 over radical. So this here is my unit vector. However, we should rationalize that, right? What is that rationalized? Right. So rationalize, you have negative 2 radical 29 over 29, comma, 5 radical 29 over 29. Is everyone okay with that? Okay. Now, when I verify that the magnitude is 1, I'm honestly going to leave it in the unrationalized form so that you don't have like tons of numbers. You get actually less numbers when it's not rationalized. Okay. Is everyone okay with that so far? All right. So let's go ahead and verify. And how do we verify again the magnitude? We look at it. We actually have to find its magnitude, right? And how do we find the magnitude of u? The square root of each term squared, right? Well, what is my u coordinate? u1. Negative 2 over square root of 29, right? What is my u2? 5 over the square root of 29. Is everyone okay with that? What is negative 2 squared? 4. What's the square root of 29 squared? 29. Plus, what's 5 squared? 25 over, what's the square root of 29 squared? Now, do you guys see why I left it that way? Okay, use that one instead of the other one, less numbers. What's 4 over 29 plus 25 over 29? 29 over 29. And what's 29 over 29? 1. And what's the square root of 1? 1. So did we verify that the unit vector is 1? Yes. Did we find the unit vector? Yes. Okay. Any questions with that so far? We all good so far? Yeah. Okay. Do you guys remember vectors at all? Did you do any in trig? I don't know if you did or not. You don't think you did? Okay. I don't know what curriculum you guys do in the trig part, so I'm not sure. Okay. Yeah, because it's short. Okay. That's a good question. That's a question I need to ask. Though I might not be teaching trig next year. I don't know. Standard unit vectors. I tend to always get new classes every year. Taught problem stats last year. Now I don't teach it. Though I might just be doing finite the first semester class. All right, standard unit vectors. Okay, standard unit vectors are just the vectors of 1, 0, whoa, and 0, 1. Okay, those are your standard unit vectors. 1, 0 is actually denoted as I. Not make sure, guys, this I is not the same as this I. Why? Obviously, this I is for vectors. What's this I? Imaginary numbers. They're not the same. So do not put that curve on the I here. Okay. Why? I don't know. So when you see I, that is actually the same thing as 1, 0 vector. Okay. For the other one, they use a J. So J is equal to 0, 1. Okay. So sometimes you'll be seeing like negative 12 or 2I plus 5J. Okay. So if I see like 2I plus 5J, that's looking at like 2 times 1, 0, which would be 2, 0, plus 5J would be 0, 5. And that ends up getting to what? True vector. 2, comma 5, right? So it's just different ways to look at that, all right? So let U be the vector with the initial point 2, -5, and the terminal point of -1, 3, where U is a linear combination of a standard unit vectors of I and J. Okay, that sounds really, really confusing, doesn't it? Okay, but the main idea here is we need to find our component vector. Okay, where our initial point is at what? 0, 0, right? So do we remember how to find our component vector? So going back to the front, how do we find the component vector? Yes, except not the square root. These are just our vectors, right? So to find that, we're just taking that Q minus P, comma, Q minus P, right? These are the 1s, the 2s. So yeah, so almost like our distance formula, except it's not the square root, it's our vector, right? So my initial, remember, my initial point is the P, my terminal point is my Q. You guys okay with that? Okay. So now I'm going to take -1 minus 2, comma, 3 minus what? -5. You guys okay with that? So my component vector would be -3, comma, 8. Are you guys okay with that? All right, so now that original point would have our initial point at 0, 0 to -3, 8. Okay, -3, 8 that way. All right, now we want to write it as a linear combination. So we want to look at it as I's and J's. Okay, this is not hard because remember, if I got, remember, 2I was the same thing as 2, comma 0, right? So that just got me my first coordinate of that vector, right? So when I'm converting this, that -3 is just -3I. Plus the 8, the second coordinate, is my J. So it's just -3I plus 8J. Okay. Why does that work? Because it's like -3 times 1, comma 0, right? 8J would be 0, comma 8. And then when I add those, wouldn't I get -3, 8? Yes. Okay. There you go. All right. Let U be -3I plus 8J and V be 2I minus J. Okay. Find 2U minus 3J. Do we have to put this in vector form or can I leave it in the linear combination here? I can leave it in the linear combination, right? 2U just means I'm going to take 2 times vector U, right? But U is the vector U. It's just in our linear combination of -3I plus 8J. So can I, for 2U, just take 2 times -3I plus 8J? Am I able to multiply 2 by that? Yeah. Then minus, we're taking 3 times V. So can I take 3 and multiply by V, which is 2I minus J? Yeah. So what would I actually do first here? I think I could do. I could just distribute. What's 2 times 3, -3I? -6I. What's 2 times 8J? 16J. What's -3 times 2I? -6I. And then what's a -3 times a -J? +3J. Now, can we combine our coordinates, our like terms? Yeah. So what would we end up getting? What's a -6I minus 6I? 12I. And 16j plus 3j, 19j. Now, just so you guys know, what is the vector? What would this vector actually be? You don't have to do this, but just asking, what would negative 12i plus 19j actually be as a vector? Remember, if negative 3, 8 went to negative 3i plus 8j, going backwards, what is my x coordinate kind of? Negative 12. And what is my y? 19. So those are the exact same thing there. So as you're looking at these, okay, if I have negative 3i plus 8j, that's the same thing as the vector of negative 3, 8, right? 2i minus j, isn't that the vector of 2 and negative 1? Yeah. So then if I take 2u, aren't I taking 2 times negative 3 and 8? And don't I get negative 6, 16? And if I take negative 3 times these two, don't I get negative 6 and positive 3? And then wouldn't you add the same coordinates? Yeah, so that's what you're doing here. It's just written in a little different form, okay? All right, direction angles, your guys' favorite, angles, theta, right? And if we're finding angles, we're using our trig functions, right? So if u is our unit vector, okay? What's my magnitude of a unit vector? What's the magnitude of our unit vector? 1, right? 1, okay. Such that theta is the angle measured counterclockwise, okay? Measured counterclockwise. So if I'm in quadrant 2, let's just say, my theta would be this whole angle here, right? Not our reference angle, but the angle to that terminal. So that's what's different when we were doing the other things, right? All right. If I'm in quadrant 3, I actually would have to find all of that. So I'd take 180 plus that reference angle, right? Things like that. All right. From the positive x-axis to u, then the terminal point of u lies on the unit circle, and you have u would equal the vector of x comma y, which means, think of this on a unit circle. The x coordinate is always what trig function? Sine, cosine, or tangent. What is the x coordinate? Cosine. So it's the vector of cosine theta, comma, sine theta. And if we put that in a linear combination, it's the same thing as the cosine theta I plus sine theta j. So all of those mean the same thing here, right? Okay. The angle theta, okay, from this, the angle theta is the direction angle of our vector. And yes, I know I spelled up wrong. Okay, if V equals AI plus BJ, okay, is any vector that makes the angle theta with the positive x-axis, then it has the same direction, and you can write, so if we're in the same direction, okay, we can write that V equals the magnitude of V times the vector of cosine theta, comma sine theta. Okay. Or we can write it in our linear thing as magnitude of V cosine theta I plus magnitude of V times the sine theta j. Okay, so depending on what form they give us. If we're in vector form, we'd use this one. If we're in linear form, we'd use the I and the j, right? Okay. All right, because of this, okay, it will follow, because of our vector, it will follow the direction of theta for V can be found actually using just our tangent of theta. And how do we remember tangent? How do we remember tangent? Isn't tangent sine of theta over cosine theta? Right? You guys okay with that? Okay. Which our sine of theta, isn't that the magnitude of V times the sine theta over the magnitude of V times the cosine theta? Which if for some reason we're given our vector, okay, our sine of theta is actually just the B over the A, isn't it? Why does that all work? Because if this is my vector, is AI plus BJ, which is the same thing as the magnitude of V times the cosine theta I plus the magnitude of V times the sine of theta J, right? Isn't the J always the B? And isn't my cosine always the A? Or my I always the A? So we can also find it by just taking the B over the A. Okay. All right. Find the direction angle of each vector. Okay. Direction angle. So we need to find what theta is, right? So the easiest one to be able to find the direction angle would be my tangent, right? Okay. So looking at A here, okay, we're going to use the tangent of theta equals, and since we're in linear form, can't I just use A and B? Which my B is B over A. So from here, looking at U, okay, looking at U is 3I plus 3J. So what is my A? Isn't that 3? Isn't my B also 3? Yeah. So my tangent of theta is going to equal what over what? 3 over 3, which the tangent of theta is equal to 1. So we know the tangent of theta equals 1. So can you guys find what theta equals? And because these are both positive, we know it's in, and it's 1. Aren't we in quadrant 1? A and B are both positive. So aren't we in quadrant 1? So when is the tangent equal to 1? I'll put them in both, but we're going to end up going to degrees, but that's fine. Okay, yep. So we know that's pi over 4 or 45 degrees. Does that make sense? All right. And remember, our direction angle always goes counterclockwise from the x-axis. So we know that in quadrant 1 will be 45 degrees. Okay. All right, for B. Okay, so B. We know my A is what number? 3, and my B is -4, right? You guys okay with that? A is always with the I, B is with the J. Okay. So we have the tangent of theta equals, what's my B? -4, and my A is 3, right? So do we know anything, okay, about -4/3? Do we know, is that pi over 4, pi over 3, pi over 6? No, right? So when we're looking at this real quick, is -4/3, what quadrant is that in? Well, it could be in second or it could be in the fourth, right? So let's kind of look at that here a second. Okay. So now we're going to be in the second or the fourth here for a second. All right. So second or fourth. That's what we're looking at. Okay. Now, think of this. My A is 3. Okay, so I'm going to keep going from this. My A is 3, my B is -4. So isn't that vector 3, -4? So what quadrant does that actually put me in? Is it in the second or the fourth? It is in the fourth. So we're actually looking at this. So here would be the vector of 3, -4. Okay. So now, if we're looking for our theta, it would be from my x-axis all the way around, right? So we know that's going to be less than 360, right? But greater than 270, right? Okay. So now, how do we find theta if we don't have these ones memorized? Actually, we can't because that's not one of our things. So how do I find theta? So how do I get rid of this tangent? Take the inverse, yeah. So the tan inverse of -4/3 is what? And go ahead and round to the 100. Okay, so -53.13 degrees. Now, obviously that's not my theta, right? Where does that -53.13 go? Isn't this right here? Right, wouldn't that be 53.13? Since it's negative, we know it would go down. That's why that was negative in that sense. So if this angle is 53.13, is that actually my true theta for this? No. Okay. Why? Because again, it's counterclockwise is what we should always find. So how do you think we are actually going to find this angle? I would take 360 and subtract off that 53.13. So what is the actual theta for this vector? Degrees, yeah, and there you go. I like drawing pictures there so I could see. Now, obviously, our answer was -53, but in that spot when you're going counterclockwise, isn't it a positive? Yes. So again, always look at 2. We know tangent was negative in both second and fourth, but you have to look at these as a vector. So where would that coordinate of 3, -4 be? That's quadrant 4. So that's why we knew we had to go to quadrant 4. Okay. All right. Find the component form. Okay. So component form, right? Of the vector that represents the velocity of the airplane descending at the speed of 150 miles per hour at an angle of 20 degrees below the horizontal line. Okay. So again, how do we find our component vector if we're given an angle measure? Okay. We at least need to put it in the form. Since we're given an angle, don't we have to use the vector v, the magnitude of vector v, times the cosine of theta I plus the magnitude of v times the sine theta j. Okay. And once we're in that, once we find each one of those a's and b's, then could I write my vector from that? Yes. Okay. Now, okay, from this, it does say we're descending at a speed of 150 miles per hour. So what does that 150 actually represent? What do you think that means? So if this is descending at 150 miles per hour, isn't it technically the length of my vector? And what does length actually represent? What is the length? So here's my length. And my length is actually my magnitude, isn't it? So do we actually have to find the magnitude of V? No, because we know the length of it from the point, initial point all the way down. We know it was 150 miles per hour. That's where he's going. So we know this is 150. Now, the cosine of theta. Now, it says that we are, that should be sine, sorry, I wrote that wrong. The angle of 20 degrees, okay? We are, now, that 20 degrees at an angle of 20 degrees below, we are descending. So isn't that like an angle of, not elevation, but descending angle, depression, angle of depression? I can't even talk. Angle of depression. So that comes from our horizontal line. So from here to here is 20 degrees. But is that what my theta is? No, my theta starts at 0, right? And goes all the way over to that. So if I'm starting at 0 and going to my x-axis and then down descending 20, so how many degrees is my actual theta? 200. Yeah, 200. Okay, again, we're descending. This is 20, but that's not my theta. My theta has to come from all the way around, right? Now, can you guys use your calculators to figure out what 150 times each one of these trig functions are? Yeah, I think so. So 150 times cosine of 200i is 140.996, right? 95 or 96? 95, okay. All right. Plus, what's 150 times the sine of 200? Like 52.30. 31. Okay. Okay. All right. And now, if we know our A and our B, can we write our vector? Yeah, what's my vector? Negative 140.95, comma, negative 52.31. There you go. So we know what that means. So obviously my initial point is 0, 0, but my terminal point, my ending point is at negative 140.95, comma, negative 52.31. Okay. All right. Any questions on that? Oh, 51.30. Okay, sorry. I heard, yes. 51.30. 51.30. There we go. Did I do that right now? Okay. Check your grades now. A force of 600 pounds, okay, is required to pull a boat and trailer up a ramp inclined at 15 degrees from a horizontal. Find the combined weight of the boat of the trailer. Okay, so the combined weight. Okay. So as we're looking at this, okay, so if we look at from B to A, okay, so from B to A, that is just going to be my force of B to A is just my force of gravity, right? Because it's that underlying straight from the boat, the weight going down, right? If I'm looking at B to C, that still is kind of a force of gravity, right? Okay. But now, if I look at all the way from A to C here, just A to C here, wouldn't that be my force required to get that boat up the ramp? So if we're moving from A to C, isn't that pushing the boat over up that ramp? Okay. And that's the force required with that 600 pounds, right? 600 pounds. Okay. So now to find this combined weight, okay, from that, we are going to take, and I'm going to just set it up for you, is the sine of your angle. Okay. So let's say angle A equals, okay, your magnitude of your required force, okay, the magnitude of your weight, which is AC, divided by the force of gravity, which will be our BA or BC, whichever one you want to look at, okay? So what is the angle between all of the forces that we're bringing up the boat? What is the angle that we're bringing up the boat here? What is the angle I'm bringing the boat up? Isn't that just our 15 degrees? Yeah, okay. What is my magnitude of the force required? 600 pounds divided by, do we know our force of gravity that we need? Our combined weight? No. Okay, so that will be kind of our X. Now, can we go ahead and cross multiply? All right, so we're gonna end up taking 600 divided by what? The sine of 15. And we get roughly how many pounds? Yeah, and I'll go 0.22. So the boat plus the trailer is 2,318 pounds, which should kind of make sense, doesn't it? All right, any questions? Okay, the main thing again, remember, you have a quiz when? Monday. And because you have a quiz Monday, okay,